Hello there, welcome back. Welcome back to Technology Innovation Hub. So it's going to be the 28th session on the Oracle architectural journey. Let me share the screen. We have been discussing SCN, System Change Number. I think we had enough information on SCN because we went through dig into practicals and a lot of theoretical information as well, and we checked on the multiple session practical as well with regards to SCA. So the rest of the information be related to SCA, and let's do it later when it comes to clustering environment and with related to tuning as well, and in the multi-tenancy architecture as well. Now today with this session, let's start checkpoints. So this session is going to focus on checkpoint, which is one of the another major background processes, one of the other critical background process to understand Oracle database checkpoints. And our focus here also going to be single instance, because this is falls under single instance architecture and non-multi-tenancy architecture. So first of all, let's get a theoretical understanding with the basics. We need to understand the basics first. After that, let's deep dive checkpoints with hands-on as well. So the very first thing is, what is a checkpoint? You can see the definition. Checkpoint is a background process, CKPT, that fires time to time at various conditions. So there are conditions for checkpoint to fire, and we can say it's a synchronizer as well. Very shortly, we can say what is a checkpoint? It's a state synchronizer. Because when a checkpoint completes, that guarantees a consistent point in the database. That's what it means. A checkpoint complete means it guarantees a consistent point. Consistent point in a sense, all the committed data 100% sync up and updated in the DBF files, as well as in the control file, the header part of the DBF file, as well as in the control files. And all the committed data in the redo file has been sync up with the DBF files. And checkpoint position has been updated. That means up to that particular checkpoint or up to that particular SCN, database is synchronized or is consistent. That's what it means. In case of a failure happens, up to that place, no recovery required. So let's try to get those things in more detail. And that's what it says. Once a checkpoint completes, it updates the control file and data file headers to advance the current checkpoint position, which is indicated by SCN. So now you can see there's a direct relationship between the system chain number, SCN, and the checkpoint. So that's why we learn SCN first and come into a checkpoint as the second step. So let's try to dig in more detail. I think this is the second statement, the explanation for what is checkpoint. Once a checkpoint completes, is update the control file. Yeah, the checkpoint complete means control file must be updated, because in the control file we have a record for each data file and it has to be updated with the checkpoint information. Checkpoint information means after that particular system chain number, it is completed. Everything has been updated to data files, and it updates the control file and data file headers. Yeah, so checkpoint is not going to write to the body of the data file, because body of the data file means what? That it has records. No, it has segments, extents, and blocks. So body of the data file will contain records. Now checkpoint has nothing to do with that. It is not going to update the touch the blocks with the records in the data file, but it updates the header part. That means this particular data file now sync up with control files up with this SCN number. That what it indicates, the header part of the data file. The control file and the data file headers to advance the current checkpoint position. That's true, because there was a checkpoint, as it is mentioned, it is a time to time process. So it working with the clock. Let's say the previous checkpoint happened on 9:10 and the next checkpoint is 9:15. That is, every 5 minutes a checkpoint happens. So what's going to happen? Now in the control file, the oldest checkpoint was 9:5. Now the next checkpoint happening up to 9:10 at 9:10. So within that 5 minutes, there's a gap. There's a gap. Gap means list of SCNs are there. Or we are telling is as a checkpoint queue. So now this checkpoint queue has to be cleared. Has to be cleared means what? All the relevant modifications have to be synced up with the data files by looking at the redo log files, and the control file has to be updated. That is what's going to happen. So that is what it mean by advanced current checkpoint position, which is indicated by SCN. So SCN is the unique number. For every transaction, there's SCN. So checkpoint queue means we can say linked list of dirty buffers. That is one way of explaining it. A checkpoint queue means linked list of dirty buffers. So dirty means what? The record or the buffer or the block which is in the buffer cache is not in the original state. It been modified. When server process fetch data, it's going to get on the buffer cache. And with the DML command, it's get modified. Definitely there's a SCN going to get assigned for that. We know that. So linked list of dirty buffers means what? Again, linked list of SCNs. Now when the checkpoint completes, so this linked list has to be updated from the previous position to the new position. Fine. So that is just to explain this particular statement. Let's get into the graphical explanation as well. So now we know database instance and SGA, and within the SGA we know the memory structures are there, and this is one of the major memory structures. Still this is to be explained, database buffer cache. Now we almost have learned the redo log buffer. We know inside and out of redo log buffer, but database buffer cache yet to be explained. And in the buffer cache, we know we have LRU, least recent use algorithm. We know redo log buffer is a killer buffer, and database buffer cache is a LRU, least recently used algorithm, or there's another name called TC algorithm. TC means touch count algorithm. So it's the same thing. Now within the buffer cache, we are going to get blocks. When server process fetches data in the buffer cache, is going to occupy space. Space means blocks. Records are going to get stored in the buffer cache. And we have, now if you get inside the buffer cache, we are going to have a hot end and a cold end, because every block in the buffer cache, or let's say if you take the buffer cache as whole also as a single memory, you are going to have the hot end and the cold end. This is nothing much. When the data is getting modified, let's say DML command is going to change the data, and that means those are going to become dirty buffers, not in the original state, as well as not committed as well, not checkpointed yet. So those things will be always in the hot end. Why hot end? Because those things are not going to become LRU. Those are going to be the MRU, most recently used. Always in use, no, because those are keep on changing. We can tell those are pinning buffers, pinning buffers. But the buffers which are not getting modified are going to move to the cold end, which is eligible to be flushed with the next database write, depending on the condition. So we are going to have cold end, that is the least recently used buffers which are not used for a long time, and the most recently used end is the hot end. So these things are eligible to be cleared from the buffer cache. Fine. Now we know this one, server process is going to fetch data from the relevant data files on behalf of the user request, and is going to store in the buffer cache. So that is the very first initiative. Whatever data has to be fetched from the data file. So depending on the SQL command, what's going to happen? The server process. We know what is the server process. We have learned that one. Undedicated shared. There's going to be shared server process or dedicated server process. So depending on the user request, data will be fetched from the relevant data files, from the relevant tables, and it will be stored in the data buffer cache. Now one thing to notice, when it's fetched, initially is put to the mid of the cache. That is the initial behavior. It will come and put it in the mid of the database buffer cache, mid of the memory. Or if you get sequence of blocks, in that sequence of blocks, within the mid of the box. Let's say if there are 8 blocks are there, out of 8, around 4 to 5. That's the middle point. So that is where the record is going to get stored, inserted in the buffer cache at the very first time. So depending on the usage of this particular record, let's say users are keep on requesting this record, end users are keep on modifying. Let's say the server process itself keep on modifying this one. Then what's going to happen? This will keep on moving to the hot end, always hot end. It will never come here because it is in use always. So that is the behavior of a record within the buffer cache. Now, if you move further, as the changes are taking place, what's going to happen? As the changes are taking place, it's going to update the redo log buffer. It's going to update the redo log buffer, which is going to update the log buffer. Server process again is going to update the redo log buffer with the changes. Server process is going to update the redo log buffer with the changes. That's what's going to happen. So these are normal activities which is happening within the database buffer cache and linking the redo log buffer as well. The original buffer will be stored in the mid of the memory, and with the changes, what's going to happen? This particular record will become a dirty buffer, which I haven't indicated here, but this will be explained because we have a more detailed session with regard to the data buffer cache. Upcoming explanations will be done, but for the time being, a modified buffer is known as a dirty buffer because it's yet to be committed, and again it is not in the original state. Fine. Now comes the checkpoint queue. What is the checkpoint queue? As I explained earlier, you can see as the things getting changed, SCNs will be assigned for each change, each transaction, and the queue increases. The checkpoint queue getting increases. You keep on aggregating. The list becomes aggregating, adding to the list. Linked list of dirty buffers. Now you can see checkpoint queue is nothing much list of SCNs. So we can see the SCN number, chronological number. We know that with the time it goes up, chronological, monotonical, we learn those things. And now these are, you can see with the time. Now this is the highest one, 1000, 10,000, 50, the highest one. And these things are all numbers, which is down the clock. So this list will be the checkpoint queue. Right? And if you further continue, see this list has to be synced up with the database buffer cache as well as the redo log buffer. Because whenever changes are happening, it has to update the redo log buffer, and whenever buffers are getting modified, again it has to keep updating the SCN because it has to be synced up. So if you continue further, you can see now DB writer, depending on the conditions, DB writer will have to update the data files, relevant data files. And there are conditions. We will learn those things in the upcoming sessions. Now you can see the DB writer will be updating either the header part or the body, depending on the requirement. Normally DB writer is going to update the body because the header part will be updated by the checkpoint. So this is, I just want to indicate because checkpoint will be one of the conditions for DB writer to write data from database buffer cache to data file. One of the conditions. We will learn that one in more detail in the next explanation. But for the current explanation, for the checkpoint, as far as checkpoint concerns, so we can see, depending on the conditions, we will learn the conditions. Checkpoint will fire. Let's say, for example, if you run an alt system checkpoint command, so what's going to happen? Alt system checkpoint will do a checkpoint called a pull checkpoint. Now, in a pull checkpoint, what's going to happen? Entire database buffer cache will get flushed. Entire means we can say all dirty buffers will get flushed. Not only the least recent use. All modified buffers will get flushed. We can't say entire because there are select queries as well. But all modified blocks will get cleared if it is a pull checkpoint. We are the DB writer to the body of the data file. And checkpoint will have to update those information in the control file, and depending on the condition, it has to now, for example, the previous explanation, I just took a alt system checkpoint. It is a global checkpoint or a pull checkpoint. Now in a pull checkpoint, control file has to be updated as well as the header part of the data file should be updated because it's a pull checkpoint where it's going to plus all the modified data to the data files as well as control file. But there is something called incremental checkpoint. For example, at log switch, when the pass start integer parameter triggers. So likewise, there are incremental checkpoints. In an incremental checkpoint, only the control file will get updated. It's not going to update the header part of the data file. Great. So that is just to give you a theoretical explanation. If I just complete this session, let's not drag this one for too long. And we know that our log writer also fires, and in between the log switch also the checkpoints are happening. We know that these are incremental checkpoints. And you can see we have learned that one again. Fine. So as far as the theoretical part or the definition concerns, to get an idea what is a checkpoint, I hope that explanation is enough. So let's continue this explanation with hands-on and with the categories of checkpoints in the next session. And I'll get into more detail with checkpoints with each category and what's going to happen. Okay, let me complete this session here and I'll meet you in the next session soon. Okay, have a great time. Bye bye.